Hi everyone, welcome to this video. This is a lab on the configuration of IPv6 address types. First, I just want to really apologize for the delay in getting this video. It took a long time and I do apologize for the delay. I've not been too well recently, but I'm back now and welcome all to this lab. So I'm not going to waste too much time. Let's get straight into the lab. So what are we doing here? Well, we've got an objective here. Here we can see four routers connected to each other. We've got Orlando, Daytona, Tampa, and Miami. So what we need to do, and we've got Key West here as well, which is connected off Miami. So we've got 5 routers connected by point-to-point wide area wide area network WAN links. Each router also has a local area network, connected to its fast Ethernet interface. Now, each LAN has one host connected. The network is comparable to an actual network, connecting 5 geographically separate offices. Each office has a LAN to which desktops, PCs, and servers are connected. So we've got actually 5 routers here. So what are we doing? So task 1, we've got task 1 firstly. So the routers have been configured with an admin, with admin as the password, at console prompts, Cisco as the password, at enable prompts, and San Fran as the virtual terminal password, VTY password. So IPv6, question number one is IPv6 addresses can be written in a number of different ways, because unlike IPv4 addresses, IPv6 addresses can be abbreviated, right? We know this. So we've got, for example, in IPv6, you've got a hextet. You've got 4 zeros in there. You can condense that into 1 0. You don't have to write 0 0 0 0. You can write just 1 0 to represent all of that. So what abbreviation technique is typically used to compress IPv6 quartets that contain leading zeros? What if more or one quartets contain all zeros? So if one or more quartets contain all zeros, what do we do? Well, if you ever think about it, quartets, right? Well, quartets, if one or more contain just leading zeros. There's a way we can abbreviate that. We can, like I said, we can abbreviate 4 zeros into 1. If we've got several quartets of leading zeros, what we can do is we can abbreviate that into just into double colon. So let's say you have 4 quartets and they're all zeros. Well, you can abbreviate that just using the double colon. That can only be used once though in the IPv6 address. So if we view the answer, just go and view the answer. So you can omit the leading zeros in each quarter of an IPv6 address. Okay. For example, if you were to assign the IPv6 address 0001, 0002, 0003, 0040, 0050, 0060, 7770 ABC, you can type that address as 1, 2, 3, 40, 50, 60, 70, 77 ABC. So I actually didn't mention this one, but you can abbreviate like that as well. You can just rip out the you can just remove those zeros. If you wanted to abbreviate, you can just remove those zeros there. But note that you cannot remove trailing zeros. If you did, you would change the value of the quartet. The IPv6 address 1, 2, 3, 40, 50, 60, 77 ABC is different from the IPv6 address 1, 2, 3, 4, 5, 6, 6, 7, 7, 7 ABC. So you can't remove basically zeros that follow a digit that's older than 0. 1 to 9, you can't. If there's a 0 after that, like here, you can't remove those. You can only remove the ones that are leading, but not the ones that are coming after. So IPv6 address that contained all zeros can be abbreviated as a single 0. You can abbreviate IPv6 address by representing either a single or quartet or consecutive quartets of all zeros as a double colon. Okay. So you can abbreviate IPv6 addresses by representing either a single quartet or consecutive quartets of all zeros as a double colon, for example. Or you could type the IPv6 address 1, 2, 3, 4, 5, 6, 7, 8, and here you've got 5 quartets of just zeros, 9 ABC. You can just take all that, you can just represent that in a double colon. Okay, like here. However, you can use the double colon abbreviation only once in an IPv6 address. Now, if multiple quartets contain all zeros, the longest set of zeros should be replaced with double colon to compress the IPv6 address as much as possible. Therefore, an IPv6 address that contains multiple quartets of zeros, such as 1, 2, 3, 4, 0, all zeros, 4 zeros, 4 zeros, 5, 6, 7, 8, 9 ABC, 4 zeros, 4 zeros, 3 zeros, 1, could be written as 1, 2, 3, 4, colon, 5, 6, 7, 8, colon 9 ABC, colon 0, colon 0, colon 1. Something you can do. You can use the double colon, and then for these quartets, you can just represent them using a single 0 or 1, 2, 3, 4, colon 0, colon 0, colon 5, 6, 7, 8, colon 9 ABC, double colon here, colon, double colon, and then 1, but not 1, 2, 3, 4, colon 5, 6, 7, 8, colon 9 ABC, colon 1. You can use the double colon once. That's the key thing there. So you examine the running it's the second question now. So you examine the running configuration of all 5 routers, and you compare the IP6 address on the WAN interfaces to the IP assignments shown in the network topology diagram. So you've got running configuration of all 5 routers, and you compare the IP addresses on the WAN interfaces, right? The WAN interfaces. You've got IP6 addresses on them. All right, you compare the IP6 on the WAN interfaces to the so the IP addresses on the WAN interfaces to the IP addresses assignments that are shown in the network topology diagram. The IP addresses assigned to each router interface should match the IP address assignments shown in the network topology diagram, or the IP addresses correctly assigned to each device. So we need to view the running configuration compared to the network topology diagram. The IP addresses assigned to each router interface should match the IP address assignments shown in the network topology diagram, or the IP addresses currently assigned to each device. So what do we do? Well, let's firstly go into Tamper router. Sorry, my lab's playing a bit up here. It's not actually showing me any prompt. Right, so let me just quickly save this lab. But what I need to do, let me just cancel. There we go, it takes me back in. There we go. So now what I need to do is I need to enter the password firstly. So we've got admin at the console, Cisco enable, San Fran is the V2I password. So let's use admin, right? So admin, right? And now we need to type in enable first, and then Cisco. So let's do show running configuration. Show running configuration. Not liking it. How about I'll just do show run from global configuration mode. So let's have a look at the IP WAN IP addresses. Just a second, sorry. Sorry, just making a quick change to my display settings on my Mac. Just want to stand on my screen. So right, so apologies guys, just bear with me one moment. Okay, so apologies for that. Just making a quick change. So let's close out of that. Let's close settings down. Cancel that. Alright, so here's the lab. just going to get the document open as well on my other screen. So yeah, we're doing show run. What we want to do is let's compare our IP addresses of the WAN interfaces. So if we look at the tamper route, let's go back to the topology. We've got tamper here. You've got serial. You've got a point-to-point link there, point-to-point link there. Okay, so we've got 000, 001. Those are our WAN interfaces. So if we have a look at tamper router, and we have a look at what addresses here, we have 192.168.100.2, 192.168.100.9. That's the subnet mask there. Okay, 252. If we look at the document and we look at tamper, you can see there 100.2, 100.9, 252 for both of those interfaces. So that looks fine there. 00 is 100.2, 001 is 100.9. Fast Ethernet 00, that's facing the LAN. That's connected to the LAN subnet there. But if we were just to compare that as well, it's 2.1, and if you look at the tamper router, it's also 2.1. So let's do the same thing now. Let's go into the other. Let's go into the other interfaces. Let's go into the other routers and check as well. So we're in Orlando now. On the Orlando router, let's do admin here, the password, enable Cisco. Now show run, just do show run. So show run, we can see 000 IP address 192.168.100.1, 001 192.168.100.5, fast Ethernet 00 192.168.1.1. So again, it's a case of checking this 000 100.1, 001 100.5, fast Ethernet 00 192.168.1.1. Okay, so if we compare them, 100.1, 100.5, 1.1, 100.1, 100.5, 100.5, 1.1. Right, great. Let's go into Key West. Excuse me. Not Key West. Password admin. Had to think about that there. Enable Cisco show run. Let's go down the config. So interface 000, no IP address. 001, no IP address. Fast Ethernet 00. 192.168.5.1, fast Ethernet 01, 192.168.100.18. Now remember, this router is not actually connecting to. It's actually connecting off this router. So it's not connected. It's not actually got its own WAN interface. There are no WAN interfaces there. You just got these two interfaces, 192.168.5.1. Sorry, it's not got a connected WAN interface. It's not got a configured WAN interface. So we just got those two fast Ethernet interfaces. Okay, so 192.168.5.1, 192.168.100.18. Let's go back into Key West. Okay, so we had 5.1, 100.18. Yeah, those serial interfaces not being used. Let's go into Daytona. Right, so admin, enable Cisco. Sorry, that enable wasn't fully tight, but looks like the lab accepted it anyway. It's so Daytona 100.6, 100.13, 4.1. That's the expected output we should be getting. So I do show run. So what do we get? We get 100.6 for 000, 100.13 for 0001, and 4.1 for fast Ethernet 00. Okay, so I think that's correct. Yeah, that is. Right, Miami, last one. Right, so we've got two serial interfaces, two fast Ethernet interfaces. We should be getting 192.168.100.10, 192.168.100.14, 192.168.3.1, and 192.168.100.17. That's the output we should be getting. So let's go into the Miami router. Password is, sorry, that was weird. Right, enable Cisco show run 192.168.100.10, 192.168.100.14, 192.168.3.1, 192.168.100.17. So 100.10, 100.14, 3.1, and 3.17. 100.17. Okay, 100.10, 100.14, 3.1, 100.17. So that looks all good, right? So that's great. So we can now we can verify the IP addresses of our interfaces there. What types of IP addresses are currently assigned to the Tampa, Orlando, Key West, Daytona, and Miami routers? Well, they're IPv4 addresses, aren't they? They're IPv4 addresses. So what's the theoretical maximum number of unique IP addresses of this type that can be assigned? What's the theoretical maximum number of unique IP addresses of this type that can be assigned? Now, you might be thinking, what is actually the question asking? Like total IPv4 addresses in existence, or are we talking about for a subnet?